All right, polynomial functions, day 2. So this time we're talking about zeros and multiplicity and stuff. So the point at which the function intersects the x-axis, it's where it intersects it, that is a 0. A polynomial function of degree n can have at most n real zeros. So if it was like a third degree polynomial, it could have 3 real zeros. That's how many possible zeros there are. An even degree polynomial has an even number of zeros or no zeros, and an odd degree polynomial has an odd number of zeros, at least one. Okay? Let's get into finding these in your calculator. So if you have a calculator, pull it out right now, and I want you to put this function into your calculator. So x cubed plus x squared minus 2x. And you get a graph that looks like that. Now there's 3 zeros right there that cross. And from this graph, you can kind of tell where they are, but let's find them in the calculator. And to find these, you do second trace. So you go to the calc menu, and you're going to choose 0. And then it'll bring up like a little spider looking thing, and it says left bound. So you go to the left bound, push enter. Go to the right bound, push enter again, and it will give you that 0, so -2, 0. Do the same thing for the middle one. Do the same thing for the right one. Okay, so those 3 zeros are -2, 0, 0, 0, and 1, 0. Then the last thing I want you guys to find, well, just kidding, so we can graph those. Now, to make sure our graph is completely accurate, let's find our relative max and our relative min. So do it the same way, do second trace, find the maximum, find the minimum. That maximum is -1.2, 2.1. That minimum is 0.5, -0.6. So we can then graph those on here and then draw that graph. Okay? Notice that we have 3 zeros that intersect, and this is a third degree polynomial, so it's an odd polynomial. We have 3 zeros, so it's right. Okay? Let's do this next one. So first, we're going to graph it in our calculator. We get this M-shaped graph. Now this one's a little bit tricky because there's 2 zeros that intersect, but then there's also a point that hits the x-axis, but it bounces back off of it, that middle point right there. So that middle point, we're still going to find that 0 in the middle, even though it doesn't completely go through the x-axis and it just bounces off. It's still technically a 0. It's just not one that intersects. Okay? So we're going to use the calc menu again to find them. So that's a -1, 0, 1, 0, and 3, 0. So we can graph those. And then we can find our extrema. So we can find those maximums. So that's -0.44 and 2.44. So we can graph those 2 points. And then we can graph our graph. Okay. Notice that we have 2 zeros that intersect, and this is a 4th degree polynomial, so we're good. The 2 zeros, that gives us an even number. Even though that middle one's technically a 0, it doesn't intersect, so you don't have to worry about that one. Okay? Now let's do this one. So the linear factors of a polynomial reveal its zeros. Linear factors can be found by writing the polynomial in factored form. So first, we're going to factor this polynomial. We're going to divide out that x, so you get x squared minus 2x minus 15. And then that factors down to x minus 5, x plus 3. You should be able to do that, no problem. Okay? Then we're going to set each of them equal to 0. So x equals 0, x minus 5 equals 0, and x plus 3 equals 0. So that x equals 0, that's already one of my zeros. That one you can add the 5 over, so you get x equals 5. That one you subtract 3, so you get x equals -3. Now my zeros are 0, 0, 5, 0, and -3, 0. Okay? Let's do this one. So again, we're going to factor this first. So that factors, you can factor out an x, and you get x squared minus 6x plus 9. Then that factors to x minus 3 times x minus 3. Since we have those two x minus 3's, we're just going to combine them to 1. So that's going to be x, and then x minus 3 squared. So then we're going to set them equal to 0, so x equals 0, x minus 3 equals 0, so x equals 3. So my 2 zeros here are 0, 0, and 3, 0. Now the multiplicity, that's really just the exponent. I don't think I wrote this, so make sure you write this. This is just the exponent power. Exponent power. That's all it is. Okay, so at 0, 0, at that x that we got it from, this x right here, there isn't an exponent. If there's not an exponent, you always assume it's a 1. Okay, this is going to go away. So the multiplicity on that one is 1, because the exponent there is 1. The multiplicity on the 3, 0 is 2, because the exponent on that factor is 2. Okay? Now, this is the same equation, we just need to graph it based on the zeros. So if the multiplicity is odd, then the graph intersects at that 0. And if the multiplicity is even, then the graph bounces at that 0. And we're just going to say bounces. I know that's not like correct math terminology, but that's all right. Okay? So let's graph 0, 0 right there. And let's graph 3, 0 right there. Now this is a third degree polynomial. It's positive and it's odd, which means that it's going to start low and it's going to end high. So it starts negative, ends positive. Now this intersects at that first one, so it's going to intersect through this. I'm going to draw this over. So it's going to intersect through that first one, and then it hits this, but it bounces off and goes up. Okay, that's what I mean when I say bounces. So you could possibly, if you had a graph right here and you had a 0 here and a 0 here, you could have a graph that bounces there, and then you'd have to have another 0. But bounces there and then intersects there or something. Okay? Now, let's just fill out these little charts. These aren't too bad. So first, this is already factored for us, which is awesome. So let's just find the zeros. So we have x plus 7 equals 0, which means x equals negative 7. 2x plus 1 equals 0, which means 2x equals negative 1, which means x equals negative 1/2. Then x minus 4 equals 0, which means x equals 4. So my first 0 is 0, negative 7, x, y. That's wrong. That should have been, whoops. I probably did these all wrong, dang it. I'm just going to write it on here. So let's go back. Let's see, how do I go back? I'm just going to write these in. So this 0 is negative 7, 0. The multiplicity there is 2. And it's even, so that's going to bounce. And I'm just going to put a B for bounce. Okay, this next 0, that's negative 1/2, 0. That has a multiplicity of 1, because the exponent there is 1. And that's going to intersect. And I'm just going to put an I for intersect. Then this last one is 4, 0. That has a multiplicity of 3. And that is going to intersect also because it is odd. Okay. Yeah, see, I did those all wrong. Whoops. Now this one, let's factor it first. You get x squared and then x squared minus 2x minus 8, which factors to x squared, x minus 4, x plus 2. Now x squared equals 0, which means x equals 0. X minus 4 equals 0, which means x equals 4. And x plus 2 equals 0, which means x equals negative 2. So that first 0 is 0, 0. That has a multiplicity of 2, and that bounces. Okay, that next one is 4, 0. Has a multiplicity of 1, and it intersects. Next one is negative 2, 0. Multiplicity of 1, and that one also intersects. Okay? Now this last one. So a polynomial has a 0 at negative 6 that has multiplicity of 2. And 2, which has a multiplicity of 1. We have to write a polynomial function in standard form that could represent this function. So x equals negative 6, multiplicity of 2, and x equals 2, multiplicity of 1. So first let's write these as factors. So we can move that 6 over, so we get x plus 6 equals 0. So my factor is x plus 6, and that's being raised to the second power because our multiplicity was 2 right there. Okay, we can do the same right here. Move that 2 over, so you get x minus 2 equals 0. That's multiplicity of 1, so we don't have an exponent there. Now we have to write a polynomial function in standard form. So we need to multiply this out. So we have f of x equals x minus 2 times x plus 6 squared. Well, let's multiply the x plus 6 squared out first. And remember, x plus 6 squared is x plus 6 times x plus 6. And you get x squared plus 12x plus 36. Then multiply that x in, or multiply the x minus 2 to that, and you get x cubed plus 12x squared plus 36x minus 2x squared minus 24x minus 72. Combine like terms, and you get x squared plus 10x cubed, or x cubed plus 10x squared plus 12x minus 72. Okay? Remember to take the quiz. I will see you guys tomorrow.